Hello my dear students, this is Akash SD and welcome to the ASD physics classes. Students, I hope so. You all are doing really great. So students, in this video we are going to start electric potential and capacitance. And here we will see how to derive the expression of electric potential due to a point charge. We will learn basics also, basics of electric potential difference, and after that we will see some important points related to the potential, and at the end we will solve some of the questions also that is important for the NEET exam and the J exam. Okay students, so let's start the video and let's learn the basic. Okay students, so as I have told you very well, see please, electric potential and capacitance. Under that we are going to learn electric potential difference concept. So let's see please, electric potential difference between 2 points A and B is defined as work done by external force in moving a unit positive test charge against the electrostatic force from point A to B along any path. Along any path means, you know very well, this electrostatic force is the conservative force. It does not depend upon the path. That's why we have written along any path. Okay students, so we are going to calculate potential difference between points A and B. Okay, so students, let's start it here. So here I have taken the point here. See please, the charged particle is going to move from where to where? From point A to B against the electrostatic force. So see here please, here I have taken, this is the electric field. Okay, and here if I talk about here, one charge Q is there. Okay, now what will happen that here, you know very well, the positive charge always experiences force in the direction of the electric field. So here this positive charge, see please, this positive charge will experience force Fe. Okay, that means it is having the tendency to move which side? Right side. Now what I will do here, we will move this charge against the electrostatic force. That means here we have to apply one force in which direction? Opposite direction. Okay, and now we are going to move the charged particle from where to where? From point A to point B. Okay, so now according to the definition, potential difference between point A and B is given by A is the initial point, B is the final point. So according to the definition, we can write here VB minus VA, that means final minus initial, is equal to work done by external force to move the charge from where to where? A to B. Per unit charge means we will divide by Q. Okay, so this is the basic definition, always applicable in all the situations. Okay, now students, if we will talk about here further what we are going to see, sometimes what will happen, most of the time you will see the definition, what will happen, the kinetic energy will be constant. Okay, so what I am going to tell you, if in case this charged particle is moving with a, which one? The kinetic energy constant. That means there is the no change in kinetic energy. You see please here, if kinetic energy of the charged particle is constant. Okay, or we can tell very well what is 0, delta K is 0. There is no change in kinetic energy. So you know very well, from the work energy theorem we know very well, work done by all the forces is equal to change in kinetic energy. Okay, and here you can see students very well, how many forces are there? Two forces are there. Both the forces will do the work here. Okay, so here we can tell work done by external force plus work done by which one? Not a gravitational, electrostatic force is there. Okay, electrostatic force is equal to how much? 0. If there is no change in kinetic energy, that means we can tell very well work done by external force is the negative of work done by electrostatic force. Okay, so if in case the particles kinetic energy is not changing, so that time what will happen, that here see please, here I am writing here, see, if delta K is 0, then this VB minus VA, we can write here minus of WE A to B by Q. Okay, this is the general definition. This is applicable when what is constant? The kinetic energy is constant, or change in kinetic energy is the 0. Students here very well, this is the very basic. Okay, so now students, after learning all these things, we are going to move for the next one here. See, remember, as I have told you, work done by the external force is the negative of work done by conservative force if K is constant or delta K is 0. Okay, so in our syllabus, in 12th Conservative force means electrostatic force. So for the electrostatic force, we can write here W external is equal to minus of WE. In 11th, we have learned gravitational force is also conservative force. So here also we can write W external is equal to minus of WG. Even spring force also in 11th, W external is what? Minus of WS. All this is applicable when what is there? Delta K equal to 0, as I have told you. Okay, remember that very basics. That's why we have done this basics. Okay, students. Now after that, the main point arises why we have learned all these concepts and all that. Is it? So see, please, students. For NEET and JEE, this question is important. Okay, so let's see the question, and we should learn the basics. Now, basics we have learned. Now we will see in a question. So see, please. Electric potential in an electrostatic field at point A and B is given by this one. Find the work done by external force and electrostatic force in moving an electron slowly. Slowly keyword means kinetic energy constant. From where to where? From point A to B. So first we'll see the question here. In the question, whatever is the given data here. So see, please, students, potential at point A is how much? Minus 20 volt. Okay. Potential at point B, how much? 40 volt. Now first we are going to see work done by the external force. Particle is moving where to where? A to B. A is the initial point, B is the final point. Okay, so see, please, we know that first part we are going to see VB minus VA is equal to what we have learned? Work done by the external force A to B by charge Q. Okay, that means we can write here work done by the external force where to where? A to B is given by Q into VB minus VA. Okay, our this formula is ready. Now we'll do here, please. Work done by the external force where to where? A to B is equal to, remember that here, electron means negative charge, proton means positive charge. So this one, this charge you have to always put with the sign. Okay, always put with the sign, very very important. Okay, alpha particle means even positive charge is there, plus 2e. Okay, so we'll write here electron, how much charge is there? Minus 1.6 into 10 to the power minus 19. Okay, VB minus VA, how much here? This is 40 minus minus 20. 40 minus minus 20 here. Okay, like this. So what we can do here? Minus 1.6 into 10 to the power minus 19, and here 60. So when you will simplify this, 61.6 into 6, it will come 9.6. So minus 9.6, 110 you have to adjust actually. So 10 to the power minus 18 joule. Na? Just basic calculation. See, please, very well. Now students, in a second part, what is given? Second part, they are asking work done by electrostatic force. So see, please, work done by the electrostatic force is the work done by the external force here. Where to where? A to B. Okay, A to B. Why we have done this? Because keyword is there slowly. Slowly means what is constant? Kinetic energy is constant. That means it will become here what? Plus now. Plus 9.6 into 10 to the power minus 18 joule. Okay, this question we have done for the basics. Okay, now after that the main thing arises. Here you can see the derivation also very important in a board exam. Okay, CBSE board exam. So see, please, now we are going to calculate electric potential at a point. Now, so see, please, electric potential at a point due to charge capital Q. Here capital Q is called the source charge. Okay, so let's see now. Electric potential at a point P in the electric field of charge Q is defined as work done by external force in bringing a unit positive test charge from infinity to that point P, again keyword, without changing its kinetic energy. Okay, without changing its kinetic energy, students. So see here, please, here we can see very well. Here I have taken one charge is there, charge Q, positive charge is there, and due to positive charge, electric field in which direction? Radially outward. All the directions radially outward. But for just to do the derivation, we have written like this. Okay, so students, what I want to do here, I want to calculate the potential at point P. Okay, and let's take the distance of point P from the charge is R. Okay, at point P I want to see the potential. Now students, what I will do here, let's take here infinity is there, now very far distance, infinity is there. So what I will do here, one charge is there, now one charge is there, test charge is small q, even you can write q naught also, no problem, test charge, okay, q naught. This test charge I will take from infinity to point P. So students, this infinity is my which pointer? Infinity is my initial point, or we can tell initial position, okay, and initial position, okay, and this P is the which one? This P is the final position, okay. So students, when you will observe that, you can see very well the distance between the charge capital Q and small q naught is keep on changing. You know the electrostatic force formula, na? K, Q1, Q2 by R square. So distance between the charges are changing. That means which kind of force is involved? The kind of force involved is a variable force. So whenever variable force is involved, what we have to do? We have to calculate work done by using the integration. Okay. So first we'll use the basic here, na? First let's use the basic. So we can write here like a VB minus VA. We'll write here. We know that Vp minus V infinity is, as the kinetic energy is the constant, so we can write here work done by the electrostatic force to move the charge particle from where to where? Infinity to P by Q. Okay, this is equation 1. Now just here very well, this is the basic. After that, students, now we'll do here, we will calculate the work done by the electrostatic force from where to where? Infinity to P. Again I'm telling, here in the question they have given external, okay, is there, but external is the negative of the electrostatic, that's why we have written like this, okay. So now we are going to see here, and this is the which one? Here this work is done by the variable force, that means what we have to do? We have to do the integration, okay students. So whenever integration is involved, we have to see the three situations: initial situation or initial position, final position, and intermediate position, okay. So students, let's take here at any point this charge q naught is here, okay, this charge q naught is here now, and this distance is how much here? This distance is x, okay. So initial position will give the initial limit, final position will give the final limit, and this q naught, this intermediate position, will give us the formula, okay. So again I'm telling here, this is the which position? Which position here? Again I'm writing here intermediate position, okay, intermediate position. If you are understanding the basics, you will enjoy it, okay. So students, what will happen that here in this situation? Let's see, charge capital Q positive, charge q naught is also positive, that means electrostatic force will act in which direction? Electrostatic force, attractive or repulsive? Repulsive will be there. This is called which one? Electrostatic force, okay. So this charge q naught is having the tendency to go away, it will accelerate and go away, but the kinetic energy should not change. That means what we have to do? We have to apply one external force. In which direction? Opposite direction. Both these forces will be balanced, and according to Newton's first law of motion, when the forces are balanced, then only this charge q naught will move with the uniform velocity or uniform speed, then only kinetic energy will not change. This basic is very, very important, okay students. Now you know very well, now electrostatic force that side, external force that side, and we have to calculate work done by electrostatic force. So students, here this very well, displacement in which direction? Displacement in this direction here. Let's take very small displacement. How much is there? Dx is there. You can see very well Fe and dx in which direction? Opposite direction. What is the work done formula? The work done formula is given by integration of f vector f dot vector d, or we can tell f d cos theta also. Now let me see here please. So students, here this one we can write here integration here, and we can write here dwe. Now very small work done from infinity to p, okay. Now what will happen that here? This is the integration. dwe is given by, students, see please again, fe fd cos theta, so this is fe. Now this dx will be positive or negative thing please. This is the initial x1, this is the initial x2, that is the final. So which one is lesser? X2 is less than x1. Again I'm telling you, this is x1, this is x2. So when you will see that x2 minus x1 is the negative, again I'm telling you, see the students here, that is the very basic. See here, this is the x2 and this is the x1. You can see very well x2 is less than x1, that means final position minus initial position will come what? Negative. That's why I will write here minus dx, very basic, into angle between electrostatic force and the dx. How much? 180 degree here, cos 180, okay. Cos 180 value how much? -1. So that -1, this -1 will adjust, and what this will come here? Fe into dx, okay. Just see here very well, see here very well. Now students, we will go to the next one now, and we'll see now what I'm saying here. See here, electrostatic force where to where? Infinity to P. What we have got here? We have got here Fe into dx. Now integration. Fe from the Coulomb's law. What is the formula here? Students, see please. 1 by 4 pi epsilon naught into capital Q, Q naught by x square into dx. Okay. Now students, we have to put the limit. What is the limit? Initial position when infinite distance. So that time x will be infinite. Then this distance will keep on decrease, and when the charge particle Q naught will reach at point P, then this x will become r. That means limits we have to use infinity to r. Initial position, initial limit. Final position, final limit. Okay students. So see please, I am going to write here the limits. Limits where to where? X equal to infinity to r. Okay. Now what are the things are constant? See please, capital Q, Q naught by 4 pi epsilon naught is constant, and here what this will become here? 1 by x square into dx. So x to the power minus 2 into dx, limits as it is infinity to r. Okay. Now students, see please. Now see, I'm writing now. Now x to the power minus 2 dx formula. Now we have to use the formula x to the power n plus 1 by n plus 1. But anyhow, this one will come how much here? By using the formula minus 1 by x infinity to r. I hope so you know all these basics. Okay. But anyhow, I will write here the, see please here, this formula I am using here. X to the power n dx is equal to x to the power n plus 1 by n plus 1. Okay. So now we'll do here please. See here students. So minus will come outside. 4 pi epsilon naught, and here 1 by x naught, 1 by x, here infinity, and here r. Okay. So after that, let's go here. Minus capital Q, Q by 4 pi epsilon naught. Put the limits please. First, which limit? Upper limit. That means 1 by r minus 1 by infinity. That means what we are getting here? No, minus capital Q, small q, 4 pi epsilon naught r. This one we have got here. This one is the equation 2. Okay. And you can see here negative is coming. Why negative is coming? Because see, force that side, displacement that side. Nah? So that's why it is coming what? Negative. Now students, we will use which equation? This equation 1 and that equation 2. Okay. So from equation 1 and 2, what we can write here? See, here I have taken charge Q naught. Now, so let me write here the Q naught here. Okay. Charge Q naught, because this charge is how much? Q naught, student. So we can see here, student, see please, from 1 and 2. From 1 and 2. From 1 and 2, what we can write here? See, again I am writing here. Vp minus V infinity is minus work done by electrostatic force where to where? Infinity to P by Q naught. Okay. Now minus 1 by Q naught. Okay. Put the value here. Minus, see here please, I am just putting the value here. Can you see very well what are the things will cancel out, students? See, this Q naught and this Q naught is cancelled out. That means what is coming here? It is coming Vp minus V infinity is equal to 1 by 4 pi epsilon naught into Q by R. This is the actual expression. Okay. This is the actual expression. Now, whenever we are talking about the potential energy in presence of conservative field, conservative force, that time reference matters a lot. And here we will take the reference what? The reference is this V infinity. At V infinity, we will consider that at infinity distance potential is how much? 0. That means from here we can tell very well the one main formula will arise here. And what is the main formula? Let me write here the main formula is here. The main formula, see, Vp equal to 1 by 4 pi epsilon naught into Q by R. Okay. This is the main formula of the potential. Remember that very well. And this derivation also very, very important. We have done with the very basic. Okay. So now students, next one we are going to see. See, some important points are there. Very important. See, electric potential is a scalar quantity. Okay. Second one, for an isolated positive charge, electric potential is always positive. Okay. Because you know very well what you know. This Vp is directly proportional to charge Q. Okay. Charge is positive, single charge. Charge is positive, potential will be positive. Third one, for an isolated negative charge, electric potential is always negative. If the charge Q is negative, potential also negative. That's why I am telling Potential is the scalar, but does not mean always positive. Depending upon the charge situation, it can be positive also, it can be negative also. For isolated, this point, isolated, single charge I am talking about here. Okay. Now students, after that, if I talk about here the fourth point, see, for a collection of charges, electric potential may be positive, negative or zero. Collection of charges means maybe 2, 3, 4 charges are there. Okay, like one charge is 7, one charge minus 3, so potential will be positive. If one charge minus 7 and the charge 3, so summation is how much? Minus 4, potential will be negative. If in case one charge plus 3 and the charge minus 3, then potential how much? 0 at a point. Now depending upon the situations, charge configuration and all that, just for the example I told. Okay, now students, next one. SI unit. So whenever we have to write the units and all that, we have to use this basic V equal to W by Q. Okay. So what we can write here? W means work done, that means joule. So SI unit is what? Joule per coulomb. Joule per coulomb. Or we will tell what? We will tell volt also. Volt also. Okay. If I talk about here the CGS unit, what is the CGS unit, students? The CGS unit is the stat volt. Stat volt. CGS unit is what? Stat volt. Okay. Now students, after that, if I talk about here the dimensional formula. No? So for work done, what is the dimensional formula? ml square t power minus 2, and for charge is how much? 80. Okay. So just simplify this. What is the dimensional form that will come here? ml square t power minus 3 and a power minus 1. Okay. After that, one more thing, please remember that here, the relation between MKS and the CGS unit. Okay. So again I am writing here 1 volt. 1 volt. Now V equal to W by Q. Now 1 volt. We are going to see 1 volt will be 1 by 300 stat volt. Why? So see here please, 1 volt means we can write from here 1 joule by 1 coulomb. Okay. 1 joule. What is the CGS unit of the work? Erg. That means we can write here 10 to the power 7 erg by 1 coulomb. How many stat coulomb? Students, 3 into 10 to the power 9 stat coulomb. Okay. So when you will simplify this, it will come here 1 by 300 stat volt. Okay. Again, I am just writing here very, very important. 1 by 300 stat volt, 1 volt equal to. Okay. Very nice. Very nice. Next one is students. See please. For NEET and JEE, this one is the important. Very basic. See. Find the work done by external force in moving a 4 microcoulomb charge from infinity to a point, okay, point P, where electric potential is 10 to the power 4 volt. Okay. So students, see please, V infinity, how much we know? 0. And potential at point P, how much it is given here? 10 to the power 4 volt. Okay. Charge particle is moving where to where? From infinity to point P. Okay. So infinity is the initial point, P is the final point. That means we can write here Vp minus V infinity is equal to work done by the external force. Where to where? Infinity to P by charge Q. Q not depending upon the situation we can write. Hence work done by the external force. What we can write here? Very basic. Infinity to P means Q Vp minus V infinity. Just put the value. Charge is positive only, 4 microcoulomb. Micro means 10 to the power minus 6. So 4 into 10 to the power minus 6 here. Vp how much given? Vp, students, 10 to the power 4 minus 0. So what this will become here? 4 into 10 to the power minus 2. How much work done is there? Na? That means this work done will be joule. Okay, even you can write 0.04 joule also, no problem. Next one, students. This is also very important for the NEET and JEE. Let's see. A charge of 10 microcoulomb is placed at the origin of XY coordinate system. The potential difference between 2 points 0, A and A, 0 is how much in terms of volts. Okay. So let's take, students, this charge I have taken. Let's take this charge is Q. Okay. So charge Q is where? This charge Q is at the origin. Now, students, if I talk about here, let's take this point is A and let's take this point is B. So point A is where? Point A is where? 0, A. That means here. This is point A. How much? 0, A. Where is point B? A, 0. How much? A, 0. So students, if you will see very well, this distance how much? Anyhow, A. Distance how much? This distance is also A. That means in the question what they are asking, the potential difference between 2 points here, okay, A and B. So students here please, VB minus VA. VB how much here? Anyhow, K into Q by A. K is the 1 by 4 epsilon naught. again minus k into q by a. That means here how much coming here? This is coming here 0.